Okay? But do make sure you pay attention to all of them, because this was applying what we wrote down yesterday about parallel and perpendicular lines. So there's that information. Sorry, I need to push freeze. There we go. So parallel lines have the same slope. End of story. The only thing that you might have to check there is to make sure fractions are reduced completely. Or what if you're given one as a fraction, one as a decimal? You would want to convert so they're in the same form. And so maybe add that caution as well. Make sure to reduce fractions completely. Or that the slopes are in the same form. And by that we just mean like decimals or fractions. For example, what if one slope was 1/4 and the other slope was 0.25? What do you know about that? They're the same. They're not in the same form, but they're the same slope. So make sure they're in the same form before you analyze and decide whether or not they're the same. Okay. And then we wrote about perpendicular lines. And that one had two conditions. And I told you I'd put an example in here, so that's what that little EX is. Those two conditions are they have to be opposite sign, one positive, one negative. In fact, let's put that in here. So one positive, one negative. If both are positive or both negative, they're not parallel, or excuse me, not perpendicular. If they have the same sign, they are not perpendicular. So that's an easy thing to check. And then they also have to be the reciprocal, which means one is the flipped over version of the other. And sometimes that's hard to check. For example, if we say one slope is 0.25, well, it's hard to know what the reciprocal of 0.25 is, right? If you do it as a fraction, it's easy, but not as a decimal. So maybe just caution on that would be careful with decimals. Some of you guys like to immediately take any fractions that you see and turn them into decimals. And I definitely don't want you to do that on this because it's harder. It's actually way harder to see that. Okay, under the example or wherever you want to put this, here's what that's going to look like. So let's say we have a slope that is 3. What is the perpendicular slope?
Oh, minus 3.
By the way, remember the symbol for perpendicular is upside down capital T. So perpendicular slope, that's what that should read to you right there. Okay, he said minus 3, or what we say negative 3, right? Do you agree? Well, the negative sign is true. Its opposite of 3 would be negative, but is 3 the reciprocal of itself? No. So what is the reciprocal of 3? No, that's the opposite sign. But what's the reciprocal? Jack, can you move up here? Like, go sit right here in front of Jeremiah, please.
Oh, minus 6?
Okay. Do we not know what reciprocal means, I guess? Here, let's try an easy one. What's the reciprocal of 1/4? Like flip, and so it's 4/1, right?
Oh, I get it now.
So put that on your paper so that you know what a reciprocal is. I'm going to draw my arrows a little bit better, but you just trade places with stuff. Okay? Yeah. Yeah, way to go. So the reciprocal of 3 is 1 over 3. And then we make it negative so that it's perpendicular. So negative 1/3 is the perpendicular slope for positive 3. Okay, let's do another one. Another example, I mean. Okay, let's say our slope is, this one will be easier, I think. Negative 3/2. The perpendicular slope is what?
2/3.
Positive 2 over 3. So change the sign, flip it over. It's easy when you have a fraction, actually. That is one, for a change, it's way easier with a fraction than anything else, even easier than a whole number. So fractions aren't always bad. Okay, and then I want to put a don't do example, or maybe I should say this is hard and show an example of that. This is harder. What if our slope is 0.6? What's the perpendicular slope to that? Do you see how that's tough? Like, does anybody know the reciprocal of 0.6?
Negative 5/3.
He does. Good job, Jack. But does everybody else? In order to have that, you need to have your fifths memorized, which is a good thing to do. 0.2, 0.4, 0.6, 0.8, and then 1. But not everybody has that. So don't do decimals. Okay? If you can avoid it, don't do decimals because they're harder to find the reciprocal. But just so you know, he was correct. It would be negative 3/5. Excuse me, negative 5/3, I mean. Okay. All right. So back to the warm-up now that we've kind of reviewed that. Tell me about these first two. Well, I guess I should ask you before that, what's the slope of both of them? Yeah, this is mx plus b form. So do you guys see the slope there for both of them is the same? So what are these?
Parallel.
These are parallel. Maybe you should do this instead of whatever that game is, okay? 2. This one is not in a form where we recognize the slope, is it? We need the y by itself in the second one, which is a quick thing to do. How do we do that?
Divide by 4.
Just divide everything by 4. For this question, we don't actually care about the 3/4 over there. We just care about what's going on in front of x. So this is 1/4 x plus 3/4. Okay, now we go look at slopes. This whole thing depends on that. Tell me about those two.
They're reciprocals.
They are flipped over reciprocals, and are they opposite signs?
Yes.
Yes.
Okay, so what is this? This is perpendicular, okay? All right, number 5. We need to get that y by itself again. How? So rewriting, we get 3/5 x minus 2. The minus 2 part isn't super important. It is, I'll tell you more about that in a second, but tell me about the slopes. 3/5 and 3/5, so these are parallel. See how this is kind of quick once you get the hang of it? By the way, please don't, I don't know where this came from, but please don't do slashes. That's for dates, right? That's not math. So use an actual fraction, 3/5. You'll see that here in a couple of places. So, all right, tell me about these two. Number 3, I mean. 2x minus 5, 5x minus 5. Are they parallel? No. Are they perpendicular? No, they are neither. Those are just random lines that happen to cross each other at some point. That's all. And that's probably the most common. It's not like we have parallel and perpendicular lines all the time. All right, next. What about those two? Perpendicular, those are opposite reciprocals. Okay. Another one that's not in a form where we can recognize the slope. So what's our steps this time? It's a little bit more involved. Subtract x. Okay, we need to get x off of the left side. Now what?
Divide by 7.
Yep, get y by itself. And so this one will be y equals 8/7 minus 1/7 x. Okay, this is also in a different form, somewhat. It's like close, but it's somewhat different. So the first one has a slope of 7. The second one is in a different, slightly different form. What's its slope?
Oh,
Do you see how it's the one in front of x? Even though it's the second term, it's still in front of x. So the slope is negative 1/7. What is true about these two? Parallel, perpendicular, or neither? These are perpendicular. Those slopes are opposite sign. One's positive, one's negative, and they are reciprocals of each other. All right. What kind of line is x equals 5?
the x.
Think about if we graph this thing. 1, 2, 3, 4, 5. And it says always x is 5. Does it tell you what y is?
No.
Nope, that means you get to pick. So it's x equals 5 all the way along this. So what kind of line is that?
Constant.
All lines are constant. It's vertical. Did you say that, Levi? Good job, thanks. This is a vertical line, right? So to be parallel, what has to be true? Or sorry, I said parallel. I meant perpendicular. If it's perpendicular, it has to be horizontal. What's the slope of a horizontal line? What's the slope of a horizontal line? Good job. Jesus says 0. Okay. If it's going to be parallel, it has to have the same, it has to be another vertical line. Is this one a vertical line? Do you see an X in there? Only? No, so that's not a vertical line. But let's go ahead and get it in the right form. If we just divide by 7, we get y equals negative 2/7. Tell me about that. What's the slope of that line? Does it have an plus x term?
No.
So what's the slope? You could think of it like this, plus 0x, right? Because it doesn't exist there. So what's the slope?
There is no slope.
Guys, you need to study your notes more. I'm going to tell you right now. We did this yesterday, and I guess we're doing it again today. Take some time to make sure you don't fail this class. It's really not that hard. Right there. What does it say? We actually talked through this exact box yesterday, and now we're doing it again. Tomorrow, if I ask you what about a horizontal line, please don't be clueless, okay? Tell me about it. What's the slope of 0 look like on a graph? Guys, if it says y equals a number, it's what?
Horizontal.
Oh, you can read. Good. Okay. Does it say y equals a number? Right there?
Yes.
So what kind of line is it? All right. It says negative 2/7. Who cares where it is specifically on the graph? But is a horizontal perpendicular to a vertical?
Yes.
Yeah. Okay. Perpendicular. Okay. Just pointing out all of this. You have all these tools, but if you don't know what tools are in your toolbox, then they don't get used, right? Has anybody ever had that happen in real life?
What happened?
Like helping out somebody working on stuff with the toolbox, and you're like, oh, I didn't even know that was in there. Okay. Obviously, it doesn't get used. Can you bring that calculator and sit it on my desk, please?
Oh,
All right, next one. What form is this first one in? The y minus 3.
Point slope points.
Right there.
Point slope.
That is point slope form. Do we know the slope?
oh, yes, we do.
What is it, Luis? It's negative something. He's looking right here. We know this is m times x minus x1. That's the slope. What does just a plain old negative sign mean? -1, okay? So the slope is -1. Is this bottom one in a slope recognizable form? No, we need to do that. How? How? Subtract x. Don't forget to leave the negative on your y. Now what? How do we get y by itself? Divide by? No, -1. And what happens when you divide negative x by -1?
Get X.
What is -1 divided by -1, please?
One.
Just
+1. Okay. So tell me about these slopes. We have a +1 and a -1. What's true about those two?
they're opposite.
They're opposite. Are they reciprocal?
Yes.
Yeah, Gabriel, tell us about that. Why? How are they reciprocals?
Because no matter how you flip, it's 1/1.
Oh, that was perfect. Do you agree? This is what he just said. 1/1 is the same as 1/1, so that we're not going to see any difference. Nice job. Okay. All right, you're going to be doing some of that today on some individual practice. Here's your next task. This is a little bit harder, so please make sure you're paying attention. We're going to put an example in your notes, but actually, you know what? Let's just grab this one and stick it in your notes. Are you going to study it?
I heard some no.
All right. Go ahead and write that, please. And yeah, anytime you need more paper, there's should be some up by the fan. I'll pause here while you write that into your note box. So, first step is to identify the given slope. Thank you. Identify the given slope. Seriously, quit doing that. What is the given slope? Yep, so given slope is 3/4. So if we're going to do parallel, what has to be the slope of our new line? Has to also be 3/4, right? So we're going to write here, we're going to try to make these notes a little bit flexible. So for parallel, use the given slope. It's the same. For perpendicular, what are we going to do? Yep. Flip over the given slope and what else? Sorry, my hand keeps moving that. And change the sign. Okay, so this is parallel, so we'll just use the given slope. Hello. Oh, awesome. Actually, we put him on that desk. Thank you, Judd. That's okay. All right, so our parallel slope, I'm going to write it down. Anything you write down and make super clear is really easier to follow and make sure you don't mess up. So parallel slope is 3/4. Same thing, right? Same number. Okay. Now we've written notes on this before, like how do we write an equation through a point with a slope? So we kind of don't need to write new notes on that, but basically now we just ignore the given line and we go write our equation through 0.89 in point slope or slope intercept form. Okay. So step 3, write the equation through the point. Now that's a little bit, it depends on what form you're doing. So let's do slope intercept form and point slope form just for a demonstration. Okay, we write y equals mx plus b. What all do we know in there right now? In just y equals mx x plus b, what do we know? Well, we know m. What is m? 3/4. We know an x, which is what? 8. We know a y. What is it? 9. We don't know a b. Or we don't know what b is, so we have to go solve for b. Okay, so if you want, you could write this little reminder. Plug in m, x, and y, and solve for b. So, what is 3/4 of 8? Anybody know? That's really what that's saying. Yeah, so 8 divided by 4 is 2. 2 times 3 is 6. So 9 equals 6 plus b. So b equals what? B equals 3. Just subtract the 6. All right, now that we know b, well, and m, we're pretty much done at that point. So write the equation. So we're gonna say write y equals mx plus b with m and b plugged in. So what will our equation look like? 3/4 x and then plus 3. Awesome. There's our equation that is parallel to the given line, but goes through a different point. How do we know it's parallel? Can you look at those real quick and tell me? Same slope. They're both 3/4, right? All right. If we did this in slope intercept form, it's actually way faster. I said it wrong. In point slope form, All you have to do is plug in the slope and the point and you're done. There's no calculating. That's why I like that form much better. So write down the raw form, y minus y1 equals mx minus x1. And all we have to do is plug in m x1 y1, which is all given. Okay. It looks like this. Y minus 9 equals, what was the slope? 3/4. Good. X minus, and that was 8. Okay, and we're done. We don't have to calculate. I like that. That's better, right? That's the equation of the same exact line as the other one. Only there's no work. Not really. We can just plug stuff in. Can you stop? Thank you. Yeah. Guys, just like I said, like for me, pick which one you like. They're the same. Oh, that's 8. Sorry. I'm pretty sure I said 8, and then I wrote 9. Did I say 9 too?
No, you said 8.
Okay. I thought I said 8. Thank you for checking that. All right. Why don't you guys try one? Okay, try that one. Were you the spokesperson for the project? Yeah, I don't know where to stand. I guess right here. Can you see from there?
I just can't read it. It's fine. I'll just copy hers later. It's okay. I'll just copy hers.
Well, if you can see it right here, just get it done so you both have it.
Thank you. Oh. Thank you.
You sure that's all you needed? Okay, so now.
No, I didn't need it. It was just her. I just wanted to.
Okay, what's the slope of the given line? That's your first step. Slope is negative 1/4. So in this case, we're doing perpendicular, which is 4/1 or just 4. Okay, now we go write our equation. If you did point slope, you're pretty much done at this point. You just have to plug stuff in. And we're going to plug in y1, m, and x1. So we end up with y minus what? 7 equals 4x minus 1. That is point slope form. We're done. If we had to do the other kind, slope intercept, honestly, I would probably just use this form and just move the stuff over. So something like this, y for slope intercept. Just add your 7 and get rid of parentheses. Did anybody do the slope intercept?
Yeah.
Awesome. Okay, on the sheet that I just handed you, here's your homework for tomorrow. Listen, please. You're going to do 15 through 23 tonight, please.
What numbers?
15 to 23. 15 to 23.
All of them?
Yep.
All of them? Like, even and?
Yep.